This is a video from section 12.5. The directions say to find an equation of the plane. Let's take a look at problem 23. We want the equation of the plane through the point 3, 2, 1, and with normal vector n, which is equal to 5, 4, 6. Now, here's the formula. Now, the formula for the equation of the plane is given by a times x minus x naught plus b times y minus y naught plus c times z minus z naught is equal to 0. Now, n, which is equal to ABC, is normal to the plane. And then the point x naught, y naught, z naught, this is a point on the plane. Now, for problem 23, we have all of that, right? So if we look at our problem, now look at the point 3, 2, 1. So if I label this accordingly, x naught is 3, y naught is 2, and z naught is 1. And for n, a is 5, b is 4, and c is 6. Okay? Now, let's come over here. Now, let's again remind ourselves, my point is 3, 2, 1. My normal vector, n, is 5, 4, 6. We can get the equation. Now, what's the equation of the plane? It's 5 times x minus 3 plus 4 times y minus 2 plus 6 times z minus 1 equals 0. Now, going a little further, we can say 5x minus 15 plus 4y minus 8 plus 6z minus 6 equals 0. Now, we can go again a bit further and say 5x plus 4y plus 6z minus 29 equals 0. And that's the equation of the plane for problem number 23. Let's take a look at problem 27. Suppose we want the equation of the plane through the point 1, 3, negative 1, and perpendicular to the line x plus 3 over 4 equals negative y, which is equal to z minus 1 over 5. Now, this line can be rewritten as follows. We can write x plus 3 over 4 equals y over negative 1, which is equal to z minus 1 over 5. And I want to draw a picture of what's going on here. Now, remember, to find the equation of a plane, we need a point on the plane, right? And then we need a vector that runs perpendicular or normal to the plane. Now, we have a line that runs perpendicular to the plane, but we need a vector, okay? So we can call this point 1, 3, negative 1, right? And remember, we have a line that runs perpendicular to the plane. Now, I want you to observe something. R, the vector R, which is equal to 4, negative 1, 5, is parallel to the line x plus 3 over 4, which is equal to y over negative 1, which is equal to z minus 1 over 5. So I claim R is parallel to the line. And if it's parallel to the line, okay, that means it's perpendicular to the plane we are looking for. So in other words, the vector R, which is equal to 4, negative 1, 5, is normal to the plane we want. So if it's parallel to the line, it's perpendicular to the plane we are looking for. That's a good thing. Now, what does that mean? Given the point 1, 3, negative 1, and the vector R, which is equal to 4, negative 1, 5, and notice how I labeled all my pieces, we can get the equation of the plane. The equation is 4 times x minus 1 minus 1 times y minus 3 plus 5 times z minus negative 1 equals 0. And so 4x minus 4 minus y plus 3 plus 5z plus 5 equals 0. And then if we simplify this out, we get 4x minus y plus 5z plus 4 equals 0. And that's the equation of the plane for problem number 27. And that'll do it for this video for section 12.5, and we looked at problems 23 and 27. Thank you.